Hello. I hope I'm audible and I'm visible also. Yeah. So we gather here today virtually to discuss a very important topic, uh, or I can say a very emerging topic that where maximum resources is going on. And before that, I would like to introduce myself with you. I'm Dr. Dibya Bora, and currently I'm an assistant professor in the Department of Information Technology, School of Computing Sciences of the Assam Kaziranga University. And my area of specialization is artificial intelligence, machine learning, and computer vision. Yes, particularly computer vision, where I mainly focus on color image processing, color image segmentation part, and medical image processing or medical image analysis using soft computing based approaches. Now, I think without delay, it would be better if we start our uh, today's discussion, right? So I'm sharing the screen. I hope it is visible to you. So let's begin the lecture. Yes, you see it right. Today, our title of the presentation is Artificial Intelligence and its Application in Healthcare. Now, main agendas that we are going to include in this presentation is introduction of AI, goals of AI, what comprises to AI, programming without and with AI, type 1 and type 2 means types of AI in healthcare industry, research work explanation, and conclusion. This part, research work explanation, is very important where we'll discuss one research that we have already conducted and we got already very good results. So at any point of time, if you find any confusion, then do just ask me or raise your hand, or you can use the comment section here to uh, means ask me the questions or queries, right? You just use the comment section, put your questions there. I will definitely going to respond it. So what is AI? See, I'll be a little faster because within very short time, I have to cover a lot, right? But in the coming time, I'll also come with elaboration of the same topic, taking more time. Okay, so let's come to this definition of AI. We know the father of AI is John McCarthy, and according to him, the science and engineering of making intelligent machines, especially intelligent computer program, is known as AI. So this is a way of making computer or a computer controlled robot or a software think intelligently. The similar manner that we or the intelligent humans thinks. Okay. The intelligent human, by the intelligent humans, you know that whom I am referring. That may not be me, but I'm talking about intelligence human. So he is John McCarthy. You can see the timeline here. Take a screenshot here. Now, a very important topic in AI before beginning any other topic is the Turing test in AI. Turing test is the test by which we can find out whether a machine is AI enabled or not. Right. So in the Turing test, you will see that these three different players are there. Actually, two players and one player is the human interrogator. Human interrogator is going to ask few questions to both the players, and the players are going to answer them. In among the two players, one player is our human responder and other player is computer. But the computer, if it is AI enabled, it will mimic in such a way that it would be difficult to find out that it is a computer. Means that it will respond the questions asked by the interrogator in such a way that the interrogator will fail to detect that it is a machine or it is a human being. Like suppose interrogator asks a question that what is the multiplication of 2 to the power e to the power 275 into logarithm of 275. Definitely, I cannot answer this question within a minute. Even if you give me 5 minutes of time, then there is very difficult that I can say that I will give you the right answer because I'm a human being. Okay, I'll take time to perform that computation. Definitely, I'm going to perform the computation, but it will take time, right? But in the case of machines, what happens? They generally uh, give the answer within microseconds also, right? Even smaller than that, depending on the processing power. So if the computer gives the answer quickly, then human interrogator easily detect that it is a machine, not a human being. But if it is AI enabled, then what would happen? That it will pause for some time. Pause for some time means it will wait for some time, and then it will give the wrong answer. So what does it mean exactly? It means that the computer trying to mimic like what a human will do in that situation. The interrogator, when he sees that, it sees that the player is taking time and then gives the wrong answer, then that he or she means that interrogator will be means what happened, that he or she will believe that it cannot be a machine. It will be definitely going to be a human being. So if happens like this, then we can say that yes, during the successfully conducted, so the machine is now AI enabled. We come to that conclusion. Okay, so artificial intelligence mean artificially imposed intelligence, and artificial by the term that we mean that man-made. So we can define AI as a branch of computer science which we can create intelligent machine which can behave like a human, think like humans, and able to make decisions like us. Why artificial intelligence is needed? Because with the help of AI, we can create such software, such devices which can solve the real world problem very easily and with accuracy, such as like health issues, marketing, traffic issues. Definitely, you'll see everywhere nowadays we are employing artificial intelligence. In fact, with the help of artificial intelligence, we can create a lot of personal virtual assistants, which might be replacing the human respondent or as assistant in the future time, right? Like, Cortana, Google Assistant, Siri, etc. Now, with the help of AI, we can build some robots which can be employed for some serious tasks, some dangerous tasks. Let me give you an example. Suppose in a bus, a bomb being detected. Bomb, you heard it right. Bomb being detected. So initially, what happens that humans bomb diffuser team will go there and try to defuse the bomb, try to neutralize it, right? But there is the risk of means human lives lost. You cannot guarantee that they can means 100% neutralize the bomb, defuse the bomb without any loss. If this doesn't happen, then obviously this will impact their life, right? So it is a very risky thing. So in such situation, we can employ robots, which is AI enabled. And in that case, what happened? It can easily defuse the bomb. And if it is a loss, then there will be a loss of only a robot, not a human life, right? You agree, na? Human life is more important than a robot. So according to me, that this is the situation. This is the seriousness of the situation which draws our attention towards artificial intelligence. Wait, yeah. Then goals of AI, two important goals: to create expert system and to implement human intelligence in machines. Expert system are those systems which exhibit intelligent behavior, learn and demonstrate and explain and advise the users. This expert system like medical diagnosis system. Then we can have a expert system created for this task also. Now, what comprises AI means there are different areas, I can say different subjects which comprises AI, not a single area. Like mathematics, biology, psychology, sociology, computer science, neuron studies, statistics, etc., etc. Because AI is directly related to our emotions, directly related to us, and we as a human being attached to many different fields, not just computer science. You agree with that? Now, psychology is equally important as mathematics is important for us or computer science for us. So we get our information knowledge from every such field, we integrate them, and then we have our AI as a main important area where we deal with those artificially imposed intelligence, right? So you can see this diagram, you can take a screenshot of this. Now, programming without AI and with AI. So means what's the difference? What you are programming today, maybe they are programming without AI. But programming with AI, what new things that it will be? Yes, you can see from this table that programming without AI is specific to some particular question or particular problem statement, but programming with AI is generic, means in nature, means it can be applied to a generic question. So in one case, means without AI, we can solve only specific question like a program for solving a quadratic equation can solve only quadratic equation. It cannot solve cubic roots equation, right? But if we enabled AI programs here, that it will be able to solve quadratic equation as well as cubic equation, and no matter what nth root we are using, right? So then modification in program where without AI leads to change in the structure. We need to change the structure. We need to add the structure, right? But AI programs need little modification. Wherever some other tasks needed, then we can easily include them because they are some independent pieces of modules which are integrated to form this programming with AI, right? Programs with AI. So it's no need to worry. So this means that modification is not quite easy in the case of program without AI, but it is quick and easy in the case of AI with program with AI. I hope it is clear to you. Now types, regarding the types, we have type 1 and type 2 AI. You will see from this diagram, and sorry for the figure because I have drawn it myself. So maybe someone will scold me for this, that what type of diagram you are. But my purpose is just to show you the types only. Okay, may not be beautiful, but this should be this should be able to show you a picture of different types. Then I can say that I'm success with that. I got success with that, showing you the type. So see, type 1 we have narrow AI, general AI, and strong AI. Okay, and this type 1 is based on capabilities, and type 2 is based on functionality. I'm repeating again. Type 1 based on capabilities, and based on that we have narrow AI, general AI, and strong AI. And type 2 based on functionality, and based on that we have reactive machine, limited memory, theory of mind, and self-awareness. Now, narrow AI means the AI where we solve the generic problems, okay, or weak AI. Narrow AI is also known as weak AI, and this is the AI where we are currently stand. Okay, this is the artificial intelligence, no doubt, right? But this cannot think like a human being. It does not have emotions. Like you can consider a Google Assistant, like you can consider Siri. So they are belonging to narrow AI. Like you can consider driverless cars. They are narrow AI. Okay. Then general AI means those AI which mimic like a human being, totally like a human being. They will have emotions, but sorry, now up to nowadays, up to today's date is 20th September of 2022. I'm recording this lecture. I'm presenting this lecture to you. Up to this moment, we are not yet successful to develop such general AI-based machines where human intelligence, machine intelligence is equal to human intelligence with emotions. Then strong AI is obviously not yet developed. Strong AI is the stage where AI machines will have much more knowledge than us, along with emotions and those other things that we humans have. This is the type 1 different type. Then type 2, based on functionality, like reactive machines. Reactive machines work only on the current perception. It is not going to use the past record, or it is not going to store the records. It doesn't have that storing capacity with it. Then limited memory means only for a certain instant it can store those events, like driverless car. It belongs to the limited memory. Theory of mind, like ourselves. The functionality will be like ourselves. Okay, but this is not yet developed. Self-awareness means more intelligent than us, more, it can perform more strongly than us. That is also not yet developed. It is under research. So I hope now this picture is clear to you regarding different types of AI. Now come to our topic of discussion. What is AI in healthcare? So AI in healthcare is an umbrella term to describe the applications of machine learning algorithms and other cognitive technologies in medical settings, cognitive related to our human brain. Okay, this is so AI in healthcare is nothing but an umbrella term to define or include all the machine learning algorithms and other techniques which can be employed in our medical technologies, in our cognitive technologies, okay, related to medical science. AI in healthcare is the use of machines to analyze, act on medical data, usually with the goal of predicting a particular outcome. Note the term predicting. So we try to predict something with the help of this AI in the healthcare field. Now, healthcare is one of the most critical sectors in the broader landscape of big data because of its fundamental role in the productive and thriving society. We all know that how much critical this healthcare sector is for us. Then application of AI to healthcare data can literally be a matter of life and death. If it predicts well, if it predicts correctly, then obviously it is going to save a human life. But if it predicts wrong, then you know the outcome. AI can assist doctors, nurses, and other healthcare workers in their daily work. Now, AI in healthcare can enhance preventive care, quality of life, produce more accurate diagnosis and treatment plans, and lead to better patient outcomes overall. Remember, I am using the term preventive because with the prediction, we can take care of that particular patient with some preventive cares. And we all know that preventive care is much more important than other cares. Which if you being sick and if the disease gone beyond the stage of control, then in such cases, then the medicines may not work properly. So prediction is important, and prediction implies preventive care. Then AI can also predict and track the spread of infectious diseases by analyzing the data from a government, healthcare, and other sources like cancer detection. This can come as an example of this. So as a result, we can say that AI can play a crucial role in global public health as a tool for combating epidemics and pandemics. Even, in the COVID-19 situation, we use AI, right? We use AI in many situations, many analysis, like to detect that what will be the next wave of COVID-19 and what will be its impact and when it is coming, like that. Now, there are few terms in AI you will frequently heard in healthcare industries, like in machine learning, deep learning, natural language processing, computer visions. These are the terms which you might heard in our healthcare sectors where AI is being employed. Now you see this diagram. This is AI, the machine learning, robotics, computer vision, deep learning, neural networks, and LP. Now machine learning means what? Machine learning means, obviously from the term you got it, that it is the way of teaching a machine, make them learn about how to behave at what situation, about at what type of inputs they are getting, and accordingly what type of responses they are showing, right? So this is one of the most common forms of artificial intelligence in healthcare. It is a broad technique at the core of many approaches to AI and healthcare technology, and there are many versions of it. The most widespread utilization of traditional machine learning is to precision medicine, being able to predict what treatment procedures are likely to be successful with patients based on their makeup and their treatment framework is a huge leap forward for many healthcare applications. So forget it, just remember that using machine learning techniques, what we try to do, we try to predict that means what type of treatment procedures will be likely to be successful in respect to some particular case. particular case in the case of particular patient, right? Next thing I already said that trying to predict that what type of disease the person is suffering from and at what stage now it is and what would happen in near future. So machine learning can be supervised, unsupervised, semi-supervised, reinforcement. There are different types. Supervised means if we already have some knowledge and based on their knowledge, we try to teach the machine. Unsupervised means we don't have any knowledge. That machine will be just trying to form clusters. Okay, trying to form clusters of similar types of data, or here in the case of, we can say similar types of symptoms or similar type of, you can say what properties. And semi-supervised means a combination of both of them, and reinforcement kind of feedback type of learning, trying to improve in the next stage based on the feedback from the earlier stage. So if you see this is the life cycle in a machine learning process, from the one gathering data preparation, data wrangling, data analysis, train model and test model and deployment. Remember, in machine learning, we have two phases, training model and testing model. Then we have this term deep learning. This is nothing but is a subset of machine learning where we specially deal with neural network with 3 or more layers. I hope you already heard neural network in artificial intelligence, but deep learning is nothing but the neural network, but it's a kind of deep in nature. Deep means we are including more number of hidden layers here. This neural networks attempts to simulate the behavior of the human brain, away far from matching its ability, allowing it to learn from large amount of data. And specifically, this type of deep learning algorithm deals with unstructured data like your image, video, etc. So very, very useful in our medical image analysis. Okay. So while a neural network with a single layer can still make approximate prediction, additional hidden layers will be helping here to optimize and refine for accuracy. You can see this here. This is simple neural network and this is deep learning. So number of hidden layers increase as input layers. Otherwise, input layer and output layer is still there. Then NLP is the way, or it is the way means you can say those applications like speech recognition, text analysis, translation, and other goals related to language. Two basic approaches, statistical and semantic. One is related to statistical techniques, one is related to meaningful techniques, concerned with meanings. Statistical NLP is based on machine learning, deep learning, neural networks in particular, and has contributed to a recent increase in accuracy of recognition. It requires large corpus of body of language from which to learn. So in healthcare, dominant application of NLP involves the creation, understanding, and classification of clinical documentation and published research. NLP systems can analyze the unstructured clinical notes, unstructured clinical notes on patients and prepare reports and then transcribe patients' interactions and conduct the conversational AI. So NLP is related with conversational AI, the way how we converse. If the machines can understand what I'm speaking, suppose I'm speaking now in English, but if I speak in different languages like Assamese or Hindi, then if the system is able to get it, this means it is NLP enabled. Okay, very important. Then computer vision, very important area, maximum research going on this area. See, during the presentation, I will try to focus on those issues where you can find more interest or where you go for further research, right? So computer vision is a field of AI that enables computers and systems to derive meaningful information from digital images, videos, and other visual inputs. Okay, other visual means unstructured inputs, and take actions or make recommendations based on that information. So this computer vision is way of making the systems understanding or deriving meaningful information from unstructured data. Means we are trying to give visions to the machine with some techniques. Either they may be digital image processing techniques or like so on, so that they can visualize those different input and accordingly they can take actions and make recommendation. This is the diagram for this. You can see human visions. I have these two eyes. You also have these eyes, right? Now with the eye, we try to gather information, and this coming to our brain. Neuron is right. You know these things. This that, like this diagram. Okay, this is banana. This pomegranate, like this. Now eye is a kind of sensory organ. You know, in case of AI, we have agent, we have environment. These agents are those we try to gather information, right? Sensory organs, like in this case, eye. So now in our case, eye, and then it transfers this information to our brain. So brain now detects that. Brain means we are talking about those different terms like neurons, axon dendrites, these things. So they will detect and see that ball. There is a ball here, bananas here, pomegranates here, apples here, naspati here, like that. Peaches here, lemons here. So that is human vision system. Similarly, computer vision means we try to enable this type of vision to the machine. I mean, this input will be provided, sensory device, like in this case, in this laptop, you can see my hand here, right? How are you able to see? Because of this camera, right? Because of this camera, you able to see my hand, my finger. So this is a sensory organ. This is sensory device. Then it is taking the input, my voice, my face, this video to that this computer, right? Then from that, after analyzing or after those techniques methodology works, it will find out that there is ball, bananas, tangerines, lemon, peaches are in that ball. So that will be the output. Now I hope it is clear to you. Human vision, this is our vision. Computer vision means these things implemented in the system or machine so that they will be able to reflect the same, or they will be able to get the same here like we humans do with our human vision system. Okay? Okay, I hope it is clear. Now, our research work belongs to this area, computer vision. Computer vision is again a very big area. Under that area is a small portion of area or a little portion of area, but very important area we are dealing with. We means I and my team was working with, and that area we are going to discuss. Okay, so like if we talk about the applications of computer vision, you will see that timely detection of symptoms of a disease, cancer detection, tumor detection. In cardiology, also like to detect anomalies, visualize arteries and the flow of blood, calculate variables in cardiac MRI, electronic segmentation, etc. Then combating COVID-19 also we use this computer vision. Then to minimize false positives, then in case of medical imaging, we use these tools to read the images, analyze them to highlight the symptoms and sign of disease, thereby giving the doctors a better understanding of the patient's current health condition. So, and another important is that in the surgery also, that's the different simulating devices, simulating walks, we can help the doctors, okay, in surgeries. Now, steps involved in a computer vision: image acquisition, you can see that, then pre-processing, then the tasks like segmentation, then there will be an area, in case of our computer science, we call it database. In artificial intelligence, we call it is a knowledge base because we extract the knowledge and keep it here. Criteria like form, size, color, texture, area, like. So in the segmentation, we try to find out some particular segment where some diseases occurring, okay, some infection occurring. Then from there, feature extraction and selections like color, texture, movements mean these will be the features. And then rotation, scale, translation, these things will be done for feature selection. And after that, recognition takes place, okay? And this recognition as an output, we can keep it in the knowledge base. So in that way, this process is going on. Main importance is image acquisition, pre-processing, then the tasks like segmentation, then feature extraction and selection, and recognition finally. Now come to the medical color image enhancement. Where did I say now a small area where we are working with? So this is the area where we work with. Okay. So basically nowadays I'm engaging in different schedules, so I got very little time to deal with. But when I was in my before 2-3 years, I was in PhD scholar as working as a PhD scholar. Then I had a very great interest on that, and I with my team did some wonderful works here. Okay, wonderful. It works from the reviewer's comment. Okay, not from my side. Anyway, so medical color image enhancement is an important area of research in the pre-processing stage of computer vision. Yes, this is related to the pre-processing stage. To improve the visual quality, resolution, accuracy of the original image, we need an enhancement technique for medical color image. And this helps to get accurate results in the further processing of the medical diagnosis process. And this is very crucial part, as the accuracy of the final results is directly depending on the outcome of this test. So in short, I can say that with the medical color enhancement, we try to improve the quality of the input color medical image, so that if we get some better image, this will help us in the further processing of the results, and that automatically implies the increase of accuracy in that medical diagnosis system, okay, or medical diagnosis process or disease diagnosis process. Now, why enhancement is needed? Why enhance? Why not direct input images? Why we need this pre-processing step here for the medical images? Answer is, medical images are often suffered from low contrast issues. Now, there again, question comes to our mind that what is contrast? See, can you see this? This, right? You can see me in the diagram. Let me. Yeah, I hope it is coming. So you can see this, right? Why? How you detect this? How you detect this particular duster from the background? Because of this technical term, contrast. Contrast is the factor by which we can recognize and detect object present in an image separately from its background. See, you can see me, and you can see that background also, that wall, those stairs, you can see here, right? You can see here. So how it is means possible to detect this type of object like me and dusters and this type of background detects background objects? Because of contrast. Okay, so contrast is the factor by which we can recognize an object and present in an image and separately from its background. And this property is totally based on human perception, how you are seeing, how you are observing. Okay, and mathematically we can define this term contrast as C is equal to Gx minus Gy divided by Gx plus Gy. Now, what is Gx here, Gy here? So Gx and Gy are the mean variables of the two regions for which contrast needs to be calculated. Yeah, this is one particular region. Some values are there. You know the pixels value, if it is considered 0 to 255. Okay, these different gray values I'm taking and taking the average. Suppose this is Gx and the background. Their average of the gray values, Gy, and then Gx minus Gy divided by Gx plus Gy will give you the contrast. Okay, so this is also known as relative brightness contrast. For many reasons, the contrast may be degraded, and many of them occurring during the image of acquisition process. Means at the very first stage of this medical image processing, these things happens. Very first step is what? Image acquisition, right? In any diagnosis process, physicians want a good contrast image so that different cells and nuclei are easily distinguishable in that image. So in medical images, what actually we are dealing with? We are dealing with some objects, we are dealing with some tumors or different objects. Basically, if we are dealing with cells, then cell and nuclei, right? Cells and nuclei, different cells will be there, nuclei will be there. So if contrast is not good, how could we detect those, or how could we isolate those different cells and nuclei, right? Yes or no? So these things happen at the very first stage, and this will definitely going to hamper the process of accurate medical image analysis or accurate analysis at the later stage. By good contrast image, it generally refers to the increase in the range distributions of the pixels within the allowable range, whatever range we are considering, like 0 to 255, 0 to 250, the range should be equally distributable. Okay. While low contrast image means the pixel distribution is confined to a very small range. Okay, very small range I'm considering, and that will be low contrast image. Then use of fewer sensors during the image acquisition process. Poor illumination imply a poor contrast image. This poor contrast image does not help in the further analysis like segmentation and makes it difficult for the physician to distinguish different objects and objects present in that medical image. And what happens as a result? What happens as a result? Wrong analysis of or wrong diagnosis, and that may result in a very what I can say dangerous way, because if that disease is not detected at the right time, then what happens? The patient may face some unfortunate events, unfortunate things like death also. Yes or no? Like detecting cancer at early stage is important. So this type of things happen if the image quality, medical image quality is not good, which we are using in this process. So that's why this is very important. Contrast is very important. Contrast should be improved before proceeding to the further analysis process. And in case of medical color image, it is more important than gray ones. Color images is more important. Why? As poor contrast may lead to the misclassification of colors, and that indirectly fuels inaccurate diagnosis results. Okay? As for example, staining images are mostly adopted. We know, probably you may not know, but in case of medical science, what I can say, healthcare field, we frequently use to stain the images so that we can properly isolate the cells and nuclei. And those are color images. If the contrast is not good, then the analysis will be very difficult for us. Very difficult is we may not be able to means properly detect the cause and reason behind that disease, or detect the disease at the right time. Such staining like AC staining that we are going to discuss within a very few minutes. Okay. Now you see that this is very important medical color image enhancement, right? Now, what are the challenges involved in the medical color image enhancement? And those who are particularly interested in this, in the research of this field, you have to focus these things very carefully. Okay, this is very important for you. Two measures and challenges that every such technique have to face. They are, first, selection of a proper color space for the color computation that will be involved in such technique. This is very important, as our main aim is to improve the contrast, but not to change the hue values and saturation values. Okay, don't mind, I am going to discuss the color space, okay, after precise. Now, if we wrongly selected, if we select a color space that is not suitable for our task, then it will result alteration of hue values, and that may result the color misclassification, and that as a result lead to the wrong identification or misinterpretation of objects for which diagnosis is conducted. Now you got it. Right. Secondly, and most importantly, while dealing with medical images, we have to consider the vague nature of the images, of such images. Remember, medical color images are of the property like vague nature. Most medical, then what does it vague nature means? This means there is uncertainty around the edges of that image. Because medical images are fuzzy in nature, and boundaries surrounding the region of interest are very hard to be identified. So traditional algorithm almost fail to deal with this fuzzy behavior of medical images. So we should especially take care of this issue. Now, what are the solution of this challenge? First, for the first problem, this is the solution. When we go for developing a technique for medical color image enhancement, the first thing we need to consider a proper color space. Okay, RGB may be the default color space, but this is not suitable for color image enhancements for medical images, because hue values are associated with each of these three channels, RGB, red, green, blue. So no particular one channel which is purely devoted to the luminance value adjustment, right? This is the main drawback of RGB, sorry. So from our own past research work, we have observed that if we employ the enhancement task on the intensity channel, then the hue values are not going to be affected. That is what our aim is. Hue values should not be affected, right? So it is recommended from our suggestion also that instead of using RGB, go for other color spaces like LAV, SSB, where there is a devoted channel to deal with the luminance values, okay, and means intensity values. Like in the case of LAV, we have L channel. In the case of SSB, we have Z channel. Then second is that as traditional methods fail to deal with such vague nature of medical images, why not to go for fuzzy techniques, right? Fuzzy based methods are able to deal with the fuzzy behavior of medical images. So it is better to go for fuzzy techniques. And also I suggest from our own experiments, go for advanced fuzzy based techniques like intuitionistic fuzzy shade or type 2 fuzzy shade. Okay, the first one I am not expert with because my works are on type 2 fuzzy shade, but we have gathered this information from the records of the already existent techniques and analysis of those results that type 2 fuzzy shade, intuitionistic fuzzy shades are more beneficial in this particular case, right? Color space. I use the term color space. What is that? This is actually specific organization of colors which in combination with physical device profiling always allows us for reproducible representation of colors in both digital and analog representation. This is a special tool for understanding the color capabilities of a particular device or digital file. So this different line, these lines may not be understandable for you. Just remember one thing, the color space is the way of organizing the different colors of an image. So according to the trichromatic theory, the separate lights are three separate lights are red, green, blue can match any visible color based on the eye's use of three color sensitive sensors. It is the way that the most computer color space operate using three parameters to define a color. So color can be described using these three coordinates of parameters which describe the position of the color within the color space being used. But if RGB is the color space, then why we go for others? If RGB is the default color space, then why we need to go for others? Because different color space presents the color information in different ways and make certain calculations more convenient and also provide a way to identify the color that is more intuitive. RGB color space define a color as a percentage of red, green, blue hues mixed together, while others describe the colors by their hue, saturation, and luminance or intensity values. Okay. Then there is one more term like device independent or device dependent. What is that exactly? Device dependent color space is the color space where the color produced depends on both the parameter used and on the equipment where it is being displayed. Like RGB. RGB is a device dependent color space. If we try to specify the same RGB color values on two different workstation, the color produced will be visually different if viewed one side by side screen. Here we have one machine, there we have one other workstation. You may see that there is different of visualization of the same image if we are using RGB color space. That means that this is device independent. While device independent color space is the one where the set of parameters will produce the same color on whatever the equipment they are going to use. Like L star, A star, B star is a device independent color space. So there are two important color spaces. They are L star, A star, B star, SSB. There are many, but I have considered these two because they are very important. You can see L star, values 0 to 100. A star, you can see green to red. Negative A values implies green. Positive A values implies what? Red values. Positive B values implies yellow. Negative B values implies blue. Okay. Then hue saturation value. These are the hue values. These are the saturation values, and these the values, intensity values. So L star, A star, B star. The central axis represents L star value that can take from 0 to 100. 0 is for black, 100 for white. Coordinate axes follow the fact that a color cannot be both red or green at a single time because these colors oppose each other. No, this is easily visible from this image. Values run from positive to negative for each axis. Then A values indicate amount of red, while negative values indicate amount of hue. I hope this is clear. Now, SSB, hue is an angle in the range 0 to pi related to the red axis, with red at the angle 0 and green at the angle twice pi by t, blue at the angle 4 pi by t, and red again at the angle twice pi. Saturation, SNL, can be defined as the depth or purity of color and is measured as a radial distance from the central axis with the values between 0 at the center to 1 at the outer surface. For S is equal to 0, 1 moves higher along the intensity axis. This means 1 goes from black to where? White. As much as we go towards that 1, this means we are moving towards white from different shades of various shades of gray. Okay. Value is a percentage goes from 0 to 100. This range can be thought as the amount of light illuminating a color. So value represents intensity center. So we have performed some operations with respect to one color image. You can see here this final segmented image in L on L star, A star, B star, and this is this one is last one is for final segmentation on SSB. If you look carefully, means if we consider the subjective analysis, then also you will see that SSB is giving more better performance because here is that onion is properly segmented. Segmentation, I hope, sorry, segmentation is a term we use for what? We use for separating the identical object in a different cluster. Means we divide the image into different groups, which are known as clusters or segments. Then inside a segment, the objects, whoever the objects belonging, they are showing the similar property or homogeneous property. Okay, good. So MSE PSNR values are also being compared. Low MSE implies better performance and high PSNR implies better performance. So consider these two tables. You will definitely say that SSB is giving better performance. Okay. Okay. Now, what is the research issue here? As you have seen, then this image is not medical image, right? So what would happen if you consider a medical image? What would happen? So that is a very important issue. In the case of medical images, which one will be better? Color space for color image enhancement or color image segmentation. You guys may note it and take it as a further research for your research of interest for your future research or current research. Okay. Now, AC stain images, because this is one kind of medical image. There may be different type of medical image, right? MRI image. Okay, means different types of medical images may possible, X-ray images. But here I am considering AC stain images. Don't forget that I am talking about color medical images. So I am considering AC stain images. So what is this? ACE stands for hematoxylin. Okay, hematoxylin pronunciation may be very different in different regions. I'm pronouncing it as means this as hematoxylin. Okay, hematoxylins, and E stands for eosin. So this hematoxylin and or hematoxylin or an eosin stain is regarded as a gold standard in histology or pathology laboratories. You may consider this very important. These images are widely used in medical diagnosis as they lead to accurate diagnosis process. Why we need this staining thing or the staining processes? Because most cells are found colorless and transparent in the case of medical images. You can consider our tissue cells, retina cell, whatever the cells you are considering, you will find that most cells are found colorless. So very difficult to, and transparent also, very difficult to isolate them, very difficult to locate them, analyze them, right? Very difficult process to analyze them. So in staining, the histological sections are stained in such a way that these cells should be visible. And AC stain is one such popular technique, popularly adopted staining technique. And here we use hematoxylin or hematoxylin also. Pronunciation I already said, that may be different. And hematoxylin and eosins are used to color the nuclear and cytoplasm differently. Why we are doing that? Because with that, it will be easy to isolate them. It would be easy to separate them. Okay. Consider this sample AC stain image. This is the image of retina. Part of the eye stain with hematoxylin and eosin. So this hematoxylin, here cell nuclei stain blue purple. You can see these blue purples, and extracellular material stain with pink. Okay, you can see here bottom portion. This is the sample AC stain image. Now, hematoxylin is a dark blue or violet stain. Remember, color is dark blue or violet for hematoxylin, and this is basic or positive by nature. And eosin is red or pink stain, and this is acidic in nature. So hematoxylin is basic in nature, and color is blue or violet, and eosin is acidic in nature, that is negative in nature, and color is red or pink stain. So hematoxylin and eosin, when we combine it, it produces blue, violet, and red colors, red and pink colors, you can say. So like other medical images, AC stain images also suffering from fuzziness near or on boundaries. See, boundaries are very important. You know, the edges, edges are very important in our image processing process or any kind of computer vision analysis. Because due to high amount of vagueness, it is very hard to distinguish the boundaries separating the different cells or ROI. ROI stands for region of interest. Because of this, there arises the need of soft computing based technique to deal with this vagueness and thereby improve the quality of the images. So we are not going to consider the traditional techniques. We are going to consider soft computing techniques here. And so in case of soft computing also, we go for higher fuzzy set based techniques, advanced fuzzy set techniques like type 2 fuzzy set here. You know the Zadeh established the idea of fuzzy set in 1965. But he found that the membership function of type 1 fuzzy set, membership function, you know now, the fuzzy set deals with 0 to 1 value. And for every value, there is a membership value, and there will be a membership function to calculate that value. But that membership function itself is containing some uncertainty. So fuzziness is not completely removed from the type 1 fuzzy set. Hence, to solve this problem, he again introduced the idea of type 2 fuzzy set in 1975. You can see after 10 years. So type 2 fuzzy set can be considered as an expansion of type 1 fuzzy set. Whatever the fuzziness we have in the case of membership function of type 1 fuzzy set, we try to deal with that with one extra layer of fuzziness that is known as type 2 fuzzy set. It is found very useful in such cases where there arises obscurity agree on the accuracy of the type 1 membership function due to uncertainty in the shape, location, or other such parameters. Proper upper and lower bounds should be used to bound that membership function. Means upper bounds and lower bounds should be there, right? In other hand, the type 1 membership function is blurred to obtain the type 2 membership function. Look at this diagram. This is the type 1 membership function. You can see this mu AX. Okay. Then next, this is the type 2. Means you can see shaded region here. Means this shaded regions means we again try to find the value of the membership value for that function. So this expansion is known as type 2. Okay. One type again being inserted above or over type 1 membership function. So mathematically, we can define type 2 fuzzy set as A type 2 is equal to X, comma mu X mu. Mu A X, comma mu, where X belongs to X and mu belongs to Jx, and Jx is a membership function having the value 0 or 1. Okay, clear? I hope this is clear. Then mu AX mu is the type 2 membership function, and this function Jx is the prime one. Now you can consider this upper and lower bound, type 1 fuzzy set, type 2 fuzzy set, upper limit and lower limit. See, you can see this, that this is the membership area, and this is bounded by lower limit and upper limit with the help of type 2 fuzzy set. So upper limit and lower limit defining the membership area with respect to type 1 and type 2 fuzzy set. I hope it is clear to you. Now there is one more term, that is footprint of uncertainty, that is also known as FOU. So this term is used to illustrate the uncertainty in the primary membership of a type 2 fuzzy set. This equation for FOU is FOU A type 2, the X goes from X to X. X means this set, and these values may be different, and this is imparted on JX. JX is the membership functions value, right? So FOU A type 2 is the footprint of uncertainty, means what will be the value of those means different values of the membership functions member in the case of type 2 means a little bit confusing, right? So just in simple case, you understand it as a set over a set. JX is a set, right? They have different value, and those different value itself being bounded by upper limit and lower limit, and so thereby each of such value will have some different value in a different set, means they are being mapped into different value in other set, and that set is known as footprint of uncertainty. The type 2 fuzzy set has the ability to cope with uncertainty in much better way than its counterpart like type 1 fuzzy set and intuitionistic fuzzy set. So it has been adopted almost all the key areas of medical image processing like contrast improvement, edge detection, and segmentation. Now, as I have said that we are going to discuss one of our proposed research technique here that is being already been published. So this is the flowchart. See, briefly I'm describing input poor contrast medical image, color space conversion from RGB to LAB taken place. See, I have said that SSB. I have kept this as a research problem for you. I am now considering LAB here. You can consider SSB for your tasks. Okay, there is some reason why I am considering here. Now input L channel to, so I am extracting L channel, then input L channel to type 2 fuzzy enhance function. This is nothing but the type 2 fuzzy functions means being employed here. Say it will output LDS channel, and this LDS channel we again pass to unsharp marks. One more post-processing technique we are applying. This is producing L double dash channel. So unsharp marks, I'm going to discuss this, don't worry. Now all L channel what we have in the case of LAB original image, that will be replaced with this L double dash channels to obtain the enhanced LAB image. Okay, we got the enhanced LAB image. Now it will be converted back to RGB, and thereby we'll have final enhanced color medical image. So unsharp masking based techniques is an old technique to the photographers to send the relative high pulse content in an image by subtracting a blurred version of the image. Right? This is a simple and effective technique to boost the image contrast and to improve the digital images suffering from Gaussian blur. This can be optically done optically by first developing an unsharp picture and on a negative film, and then using this film as a mask in a second development stage. So unsharp marks work on the basis of it. So in short, I can say that you have an image and you have a blurred version of this image. The subtracted blurred version from that image, you will get what? Unsharp sharp image, or you can say enhanced image. I'm repeating again, you have an poor contrast image and you have the blurred version of that. You subtract the blurred version from the original one, then you will get the sharp or enhanced version, and this is what methodology that unsharp marks is working with. So experiment and result analysis, we have considered AC-stain image here, and results are compared both subjective wise and objective wise. So you can see here, these are the image, original AC-stain image. So I have said here that I am using L channel here, but as I have said that you can use SSB channel here, because SSB is obviously giving more better performance than LAB. So here I am going to show you the outputs for SSB channel. Although I have the results for LAB channel also, everything is same. Only the thing is that I am using SSB channel and V channel instead of L channel. So if you see the results, these are the results: original AC-stain image, SSB conversion image, V component, histogram of the V channel, enhancement done by the method SSU ETL, and then next one means you can see from the EF this marking, then enhancement done by GU ETL, then enhancement done by SSU ETL, and finally this is the enhanced image done by our proposed method. So if you compare this subjective wise, so you will see that the cells and nuclei here are clearly visible. Maybe this sounds strange for you, or you can say that we don't see little bit difference here, but the experts will find the difference here. The expert mean I'm talking about medical experts, and they can find this image. The last one is more clear, or can say the more clearly visible cell and nuclei in the last image. And we have done the subjective analysis with the help of such different experts. Then with the help of objective analysis also, we evaluated the performance, and performance for that we are using entropy and PSNR. High entropy and PSNR, high PSNR value implies better performance, and we got it for our proposed method in comparison to the other methods in comparison. Okay. So we can say that fuzziness is removed to a satisfactory level and the boundaries are clearly visible. So making the objects clearly distinguished from each other, or distinguishable from each other in the case of our proposed method. Okay. So we can say that our proposed method is performing better with respect to the other methods in comparison. So overall suggestions, what we want to put here is that selection of proper color space is very important. Then second is that go for some noise reduction technique, but be careful to apply noise reduction technique before image enhancement process done or contrast enhancement process done, because otherwise if you apply this later on, then this will amplify the noises pixel also. So noise removal technique should be employed before the contrast enhancement technique. And we can suggest that adaptive median filter is very good choice for this problem. Then third, that they carry these medical images carry a level of vagueness. So go for fuzzy techniques than our traditional techniques. Okay. So and in case of fuzzy also, you'll find better result in the case of advanced fuzzy logic based techniques. Like in our case, we have to use type 2 fuzzy logic. And lastly, but most importantly, suppose if you want further enhancement, then go for using some post enhancement process. Like in the case of us, we have applied unsharp masking. Okay. And I want to show you some published research work in this area from our side, like this one, medical color enhancement, problem challenges and vision techniques. Like this one, an efficient technique for medical color enhancement based on interval type 2 fuzzy logic. Then this one, contrast improvement of medical images with advanced fuzzy logic based technique. Then this one, enhancing AC stain images through an adapting advanced soft computing based adaptive ameliorated CLAHE. CLAHE stands for contrast limited adaptive histogram equalization. Then this one, AC stain image segmentation using an innovative type 2 fuzzy shade based approach. And this one, a local type 2 fuzzy shade based technique for AC stain image enhancement. And this one, big data analytics in healthcare, a critical analysis. And this one, an analytical study on different image segmentation techniques for malaria parasite detection. Then this one, segmentation techniques for MRI, brain tumor images, a critical study. And many more are there, but I'm not including them. But you can search this very easily if you type my name, Jyoti Bora, in Google Scholar and my area of research, then you'll find a lot of research work. But I suggest that go through this paper, and this will help you to build a standard setup for starting the research work in this medical image enhancement field. Okay, very important area in computer vision, or you can say healthcare, AI application in healthcare, right? So we have seen that what is overall, if I can conclude, if I'm going to conclude this session, then I can say that here we have seen that what is AI, its type, its different terminologies related to it, then why AI is important in healthcare, different branches of AI which are being applied in this healthcare industry. And then we have particularly selected one such area like computer vision, and there we particularly targeted medical color image enhancement, and there also we are dealing with particular medical image type like AC stain images. And then we discuss thoroughly our proposed research work in this field, right? And we have also discussed some suggestions for better performance or performance improvement in this domain. So in the whole presentation, I try my best to show you all the research works on which the interested students, scholars, academicians like you can do some research work and contribute in this area. I know that you are already doing some research work and you are more you are having more knowledge on such research works that you are doing now, but you can add these works to your interest also, because they are very interesting and they are very applicable, very much applicable, and that will serve some good things in the society. Okay, that will bring some good social welfare, means very good in the sense of very impactful social welfare, because after all, our health is the most important thing. If we do something that will help us to take care of the health, that is what we can say that the most important thing in this case. So with this, I can conclude my lecture in one sentence, that artificial intelligence is the trending term nowadays in healthcare, which is going to change the picture, or you can say that we have already changed the picture, but many things to do in the near future. Okay, that's for us, that's for you, me, and all of us. So with this, I'm concluding my lecture. Thank you very much, and your comments are most welcome in this case, so that we can discuss more, we can have some contributed research work, right? And thereby we can build a strong base for this artificial intelligence and healthcare industry research works. Thank you very much. I'm signing out now.